All right, good morning, everyone. Thanks for showing up bright and early on a Thursday morning. I know coming from the Midwest, this was awfully early for me, but the couple house cleaning tips just to get started. Evaluations will be sent out after the OSP Expo is completed, so if you get a chance, please fill those in. There are certificates online that you can register once you've had your badge scanned. And then there is a raffle, so make sure you pick up your ticket after the presentation, and then you can put it in the barrel for the raffle. So, just to get started, my name's Todd Loeffelholz. I'm a Senior Business and Development Manager for TE Connectivity. I've been in the industry about 17 years now. Started in the cable space, migrated into the more traditional copper type portfolios, and then and now for about the last 10 years been working on fiber. So I've worked in the US, I've worked in Asia Pac, heavily involved in the Australia NBN initiative, so a lot of what's going on in Southeast Asia. Lived 8 years in China. So I have a decent background in what's happening around the world, what's happening in the US, was involved in the initial Verizon rollouts when they were happening and took that experience into Asia Pac. So what the focus is today is kind of what to think about as you're migrating from a DSL to a fiber network, and then what to think about with PON type of architectures and kind of what's going on out there. So I tend to have kind of more of an open seminar, so if you have any questions along the way, please feel free to ask. I don't mind at all. We'll kind of tackle it. So, you know, as you're rolling out and looking to migrate from a DSL to PON network, you know, a lot of the things that you have to think about is around the government. You know, that's probably one of the biggest hurdles and challenges is getting close to the municipalities and the cities and making sure that you've got the permits in place. This tends to be one of the biggest obstacles that carriers, municipalities, everybody runs into as they're migrating to a new network. So look at stuff like obtaining the permits, getting your easements in place, and even what you can do to kind of work with them to relax potential specifications that are already in place. And the best way to do this is just get closer. The closer you are to the cities, the better chance you'll have of getting these permits in place. There's also incumbents that you have to work with. There's a lot of pole type issues if you're trying to do an aerial network. So just kind of be thinking about what do you want to accomplish, how are you going to do it, and then what do you need to get in place for that to happen. The other area, which is a little bit more manageable, and especially with the help of contractors and consultants, is around your internal side. What kind of training do you need to go through? Especially in the DSL world or the HFC world, people are not used to all the fiber, all the splicing that has to happen. It's the amount of fiber that you need out in your network extends quite considerably. So as you're walking out and you're building your network, you got to really make sure you got your training in place. Make sure the people understand what they're doing. Look at how are you going to promote it. One of the biggest challenges is promotion, making sure people actually know that you have a new service, what's available. Getting out there, you know, we've seen everything from block parties to free laptops to, you know, just a number of different services that people put out there just to help promote the fact that they got a new service and this is available for the customers. But the other side of it that's probably even more challenging is how do you migrate your existing services over to the new platform? Make sure you understand what technologies you'll need if you want to continue to kind of maintain existing services, or are you going to look to eliminate them and then bring on new services as you move over. So just kind of simple areas you want to be thinking about. Financing is probably the third big hurdle is, you know, do you have enough money to roll out this network? Can you work with the cities and municipalities? Will they help contribute to it? We're seeing a lot more people looking at it as a utility, especially around the world. They're saying, you know, fiber is just another pipe into your house. And how do you do this? We're seeing some municipalities around the US going down that same route where they're kind of putting it in as a service charge. And so we'll build the network, we'll put it in place, but here's a service charge that you're going to get on your monthly utility bill. So there's a lot of different options, and it's about kind of really understanding what those options are and what you're thinking about. So the other side, so as you look at a full fiber network, what are the main things to be thinking about? You have upgrade paths, you have architectures, you have Do you want to go connectorized? Do you want to go splice? Do you want to go cascaded? Do you want to go distributed? And even within that, what do you have to do in the future to maintain that network? Is it simple to maintain? Can I use general contractors? Do I need specialty kind of splicing contractors that can help maintain the network, turn on customer service, turn off customer service? You're looking at your splitter ports. How am I going to continually utilize my splitters are out there? Or what do I have to do to make sure that I don't strand a lot of splitters once customers start turning off services, turning on? So it's a lot of things you got to think about as you're looking at making sure you're labeling properly, the technicians are trained so that they know what they're supposed to be doing in the network. So it's, and there's a lot of interesting new architectures starting to really develop and come out, and we're seeing more popularity around, there's one where they call fiber feedback, and they'll basically they'll shoot a big fiber line down of 48 or 72 fibers, and then they'll use 12 fibers over and over again to connect homes with. And so they'll splice into those 12, go east and west to the next set of houses, and then they'll go down to the next spot and they'll splice in those same set of 12 fibers east and west again and connect into them. So it's a different way to get better usage of your fiber counts that you're out in the network. And then they'll use the backbone fibers to kind of as a way to hook into those 12. So there's just lots of different ideas out there, and it really gets down to what makes sense for you as a carrier and a provider is what makes sense for your network. So one of the really big things people talk about is cascaded versus distributed, and this is probably one of the biggest discussions I have almost every week when people look at, does it make sense to go a cascaded network? I want to have multi-levels of splitting. Oh. So on the right-hand side, you'll see the cascaded, you have a main splitter, and then you feed out to multiple splitters that are out in the network. And there's some really good advantage to this. It's, if you look at Asia Pacific, that's predominantly the architecture that's used out there. And the nice thing is, especially in an MDU environment, which is heavily in Asia Pacific, not as heavily in the US, but you're not trying to pull higher fiber counts through the building. And so you're utilizing fewer fibers to build out the network, and it makes the path, the build out a little bit simpler, a little bit less fiber cost, but it comes with some limitations. The biggest thing is that when you go to upgrade, you look at your copper networks, they've been upgrading technologies over technologies year over year. Fiber is going to be similar as we go through the future. It's going to continue to upgrade. And the one problem with when you distribute your splitters, you can't basically go in and just upgrade your technologies. You have to go through and upgrade all your splitters at once. If you're in a centralized configuration, you can have a standard PON splitter today sitting next to a DWDM splitter in the future, and then the customers that turn up to DWDM, you just plug those in to the output ports. So you can have them side by side and just be migrating people up. If you go distributed, you got to have everybody that, if one person turns on DWDM, you got to basically turn everybody on in that whole section, DWDM. So it's something to think about as you look at your network. How long do you plan on utilizing your network? Is it a short term, 4 to 5 years? Is it a long term, 15 to 20 years? And as you think about that, think about upgrades. You want to be looking at that. The other side of the centralized is you can cascade, or you can defer your cost of your splitters, because you can put in initial splitters, and as customers turn up service, most cabinets or whatnot will supply up to 72 or 96 or 288 customers. And so as the first 32 customers turn up service, you can basically put in one splitter and feed those 32. As soon as the customer 33 turns on service, now you add in another splitter card and you feed those next 32 customers. And in a deferred architecture, because of the way customers are kind of out in the network, you pretty much have to put all your splitters in day one. You don't have that deferred option as necessarily as good a thing. So it's something to think about. It's a way to help kind of defer costs as you build your network and kind of look at a pay-as-you-grow model. So I think I've hit most of the main points. The other side, probably another big thing to think about, and kind of more the positive side of the distributed splitting, is you tend to have smaller boxes. Because you're pushing your splitters apart, you're not doing so many in one location. so many customers being fed off one location. So you can have a small box of like 1x4 splitters that feeds out into the network that hits boxes of 1x8 splitters. Versus if you do a centralized, you tend to have larger, 72, 288 count type of boxes, and those tend to take up more room. So just another thing to be thinking about if you're really cramped on space, especially in an MDU environment, and you're looking at an old brownfield MDU, you're trying to pull cabling through it. A cascaded pond will be easier because the cables are smaller, the boxes are smaller. It's a little bit simpler, but then you run into the future problems of how do you upgrade. One of the things that's coming out now, we're hearing a lot about new technologies coming to market. G.fast is a big one that's really kind of coming quick, and what it is, it's a technology that can really do a high bandwidth over short copper distances. And so it's really, making big strides in Europe around how do we utilize our current copper network as long as possible. And so there's some really good things about G.fast. It's going to have, pretty high bandwidth. Right now, they're saying maximum 1 gigabit. That's probably theoretical. For the standard G.fast that's coming out today, they're looking more to 300 to 500 megs over 100 to 200 yards. So it's a pretty short distance. If you get over that 200 yards, you're pretty looking at closer to VDSL 2. So it is a short distance technology. But the one side of G.fast is it's not like a DSL network in per se. It's more like a PON network with an add-on at the end of it. So because G.fast is very high bandwidth, it needs after it hits that 200 yard spot, it needs something that can transport back at the same speed that it's transporting at. And VDSL technologies cannot do that. So you need more PON technologies. Some of the active suppliers are actually developing platforms that will transmit right back from the G.fast modem all the way back to the central office or head end. So there's definitely, it's got some pros to it. The negatives are it's still 1 to 2 years out. I think ALU is still saying probably early 2016 before they're going to be ready. So as people are looking to upgrade their networks, the one thing you can look at is building a PON backbone and then utilizing a G.fast last mile as the technology ripens and comes out to market. Because at the end of the day, and I'll show it a little bit ahead of us, the last mile connection is going to be your most expensive connection that you have. So it's the most expensive part of the network, and it'll be 2 to 3 up to 5 times the price of passing a home. Connecting it is the expensive part of building the network. So it does have some nice advantages. It also, G.fast, what it can do is it's backwards compatible. So if your customers have a VDSL modem in their house today, and you want to upgrade to G.fast, that you don't have to replace that modem. They can sit on that same modem, the G.fast will connect into it and talk to it just like it's a VDSL technology. Now in the future, if that customer wants to go from 70 megs up to 200 megs, they'll have to get a G.fast modem. And then so all you have to do is basically it makes the upgrade path easier for the customers so they can replace that G.fast modem and replace the VDSL modem, upgrade to the G.fast one, and then they're up and running. Now, if that customer wants to hit 1 gig or 2 gigs, 3 to 5 years out, now you just drop a fiber from that G.fast point into the home, and now you got a full PON network with the ONT basically inside the house. So it does have a nice upgrade type of path, and you can kind of get money as they upgrade bandwidth versus having to kind of push everybody onto the same high-speed band and pay for everybody to upgrade at once. So I think it's a good technology. It's just making sure you're utilizing it in the right way. And then, between now and when it launches, are you building the right backbone networks to make it work? Is probably the other key ideas to be thinking about. The other thought is, it is a step technology. Ultimately, fiber to the home is probably going to be where everybody ends up at. G.fast, basically if you look at copper technologies, it was copper from the central office to your home, then they moved out into a node to your home, and so we started with ADSL, then it was VDSL, now it's G.fast. So it's just pushing closer and closer to your home, and eventually it'll go fiber to the home, because that's fiber's going to be about the only thing that can handle the bandwidth as the technologies continue to advance. So, I kind of mentioned this earlier. Technologies around connectorization versus splicing. It's a very big discussion, and there's a big part of it depends. It depends on what you're trying to do. It depends on, are you contracting out the workforce that's building your network, or are you going to do it yourself? And then it depends on, what's the skill level of the people that you have available to you. So when you look at connectorization, the one nice thing is it's very low skill labor. As long as they know how to clean a fiber optic connector, that's about all they have to do. Versus splicing, you have to be fairly well trained on the splice equipment. The technician's got to have a fairly expensive piece of splice equipment available to them. And so you tend to pay a lot more. And if you look at rollouts, in Australia, the biggest challenge NVN had was splicing their network together. That delayed them almost 2 years. It was an area that they weren't expecting, and it cost them significantly. In the end, it probably cost them the election. And it's interesting to say, but their national broadband network was the #1 topic of their election, and the inability of them to get it delivered is what really hurt them a lot. And then you look around the U.S., cities that have been big on fiber deployments and have just slowed down to a crawl as they're trying to get their splicing done. So splicing is a concern, and you got to really look at, do you have the ability, because a VDSL network, you're only splicing a few fibers. In a PON network, you're splicing every connection as it turns up. And as you're looking at the backbone of the network, you can really have a crew and team that's in building your backbone and splicing that in place, while a general contracting team is out actually just connectorizing it and putting it in place. The nice thing is when you have the backbone network built, it's just a general contractor that can go out and hook up service to somebody's home. And there's different ways to do it. I mean, there's the hardened connector systems that basically, it's a solid box. You just come in, you plug into it, you're up and running. You don't have to open it. A lot of contracting firms charge to open a box. And it's a flat rate fee. I got to open this box, therefore I'm going to charge that fee on you. So when you're looking at it in a hardened sense, you don't have to open that box. You eliminate that charge. Now you just have to lash the cable in place, plug it in, and away you go. On the other side of that, there's a lot of nice portfolios around internal connectorization. So you still get rid of the splicing piece. You don't need a specialized contractor, but now you have to, so it's, at the end of the day, it's a lower cost. The hardened connectivity systems cost more money. They're a lot more rugged. So you can look at an internal type of connectorization systems where you open the box, you plug in the drop cable to the subscriber, close the box, and away you go. But now you kind of end up back into that opening, closing the box situation. Now it's an easier open and close typically in especially some of the new housings and closures that are out there. But it's more of a negotiation at that part with the general contractor of how much they're going to charge you to open that box. And then you get back to just the basics of, I'm going to have a drop cable come in and then I'm going to splice it in place. But as the other side of this that you got to think about is, are you going to deploy 100% of your homes at once? If you you're pretty much, everybody in the community is going to turn up service, you're going to go in the first time, hook up everybody and walk away, splicing might make more sense because I have a crew out there, they're kind of hooking everybody in place, and then they're moving on. In most cases, people are building the backbone network and then customers are calling in and turning up service. And then so people are going out individually, turning up people's services. And now you're having individual people going out and splicing in place every time somebody turns up service, every time somebody disconnects service. It's a lot more issues and hassles to manage that. So you want to think, connectorization, especially in the fact that this part, just turning up people's service, if you look at typical homes passed on the passive connectorization piece, labor to do it and the connectivity to put it in place, you're looking in the range of $200 to $300 a home passed. If you're looking at connectorizing or connecting people's homes, you're typically up in the $300 to $500 range. So you're spending a lot more to get people connectorized. And as your take rates go up, that cost goes up with it because you think about it, it's $200 to pass a home, and now if I have 25% of the people I'm spending $300 on, that that gets divided out, so now it's $75 a home that basically gets added on. So my $200 becomes $275. Well, now if all of a sudden I have 50% take rates, that $200 becomes $350 per home passed to get to basically connectorize. So take rates are a big part of what the cost of your network is. And you normally think, hey, the more people I have, the better, but actually when it comes to capital and getting them hooked up, the more people you have, the more expensive it is. And some of the other areas that kind of go along this line, the last mile connection is extremely important because you can do a lot in between that and it has little impact on the home pass cost. You can look at cabinets, you can look at closures. There's a lot of different ways to do it, and you'll vary your home pass cost a little bit, but not tremendously. It's that last point connection is where a lot of the focus and the cost is at. And so one of the things I wanted to highlight, and that we've done a lot of modeling on this just to really help our customers as they deploy their networks. And you want to look at your drop cable lengths. How far are you dropping that cable? Because most contractors will charge per foot. So the further you drop that cable into somebody's home, the more expensive it is for you as a carrier. And so you want to look at where that drop point is at and where the home's at. And if you look at it, I started originally in the MSO industry, and I never really thought about it, but the MSOs were always around 4-port taps. They had 4-port taps all the way out in the networks. They were big on the 4-port tap, and at the time I never really thought much about it, but when you started modeling, you realized the 4-port tap's there because it fits the 4 homes around it, and they have very, very short drop lengths to the home because that's where they get charged the money. And so same thing in the fiber network. As you're looking to drop fibers off of a tap point into the home, the smaller that tap point is and the shorter your distances to your home is a better thing. It's in the long run, it's cheaper than to have one tap point and then running long lines out in a star network. So you want to kind of look at that and model that as you're building your network. And as I mentioned before, splice architectures, home pass cost $245 versus at a 25% versus $325 in a 45% range, versus connectorized, which looks down around the $210 to $255. Especially as you go higher and higher in your take rates, connectorization makes more and more sense because it's quicker to do, it's easier to do. And but at the end of the day, I am very available to talk to about this. So if you want to talk more, I can walk you through models that we've built, and we can talk about what's different about your situation versus maybe what we've modeled in the past. We have a lot of models on a lot of different types of networks. Around the world, we build models on kind of everybody and how everybody's done it. So there's a lot of knowledge that feeds this, but at the end of the day, it's kind of up to what makes sense for each person and their network. So, what are you looking at when you build your network? It's really around, the paradigm that always sits there. Quality of the network, total cost of deployment, so quality, cost, and time. That's really the areas that you want to focus on as you build your network. And you look at, I have lots of pictures and examples of what happens with a poor quality network. 3 to 5 years, the boxes are sitting open. And you look at, do you want to have, I mentioned earlier about hardened terminals. The nice thing about hardened terminals is that as you have contractors going out there, what we've seen is a lot of times contractors will open a plastic box, they'll hook something into it, and then they leave it open and they walk away. And so you end up sitting there with that fiber and the connectorization exposed. The nice thing about hardened terminals is that there's no internal handling of the connectors or of the cabling of the connectors. They can't leave it open when they're done. It's a fairly well sealed system. The other side of it is that we've seen a lot of issues where especially unskilled contractors will break fibers because they're inside. Some of the boxes have very small fibers that are being utilized inside of them. So you want to make sure that if you are going to go internal, make sure that you have 2 millimeter jacketing, at least 900 micron, potentially 2 millimeter jacketing around the cabling. That way it's got a little bit more robust kind of nature for the technicians. The total cost of deployment is very much around the initial day one cost. How much does it cost me to deploy my network, and then how much does it cost me to really turn on customers and things. So you want to be looking at the overall picture and not just focusing on the material cost versus the labor costs. in a material versus labor cost, it's the material looks great, the labor gets really expensive. You want to kind of look at the two as a all-encompassing what makes sense and how do I get the cost out of my network the best I can. And then, time to install is definitely, the faster you get your network up and running, the quicker you get returns on it. So you want to be looking at systems that help connectorize. And I know we're working on some new technologies where we basically, it's connectorization from the backbone. So you build your backbone network and then you basically just connectorize all the way out to the home. So it's very quick, easy to install. Networks that work well for people that don't build networks often and don't have big labor forces to help work on it. So there's definitely areas that you can work with and look at to help kind of speed up your installation and times. And I guess everybody's quiet this morning. They run through pretty quickly this morning. So just kind of, in wrap up, there's a lot of things to be thinking about. Make sure you're working with people that have done it before. There's a lot of good suppliers that know a lot about the networks. Talk to different ones, figure out what makes sense. Make sure you know what you're trying to do. Are you just trying to build a database network, or are you trying to really go after and build a video, voice, IP? Are you looking at wireless? Is wireless kind of a next stage thing? Do you want to use your network to expand and grow out into a wireless network and utilizing the PON as a backbone for that wireless network? There's a lot of different potentials that you could do. You can kind of use your PON network to grow a Wi-Fi network off of. So it's something to be thinking about is how do you want to utilize that PON network once it's there? It's a very high bandwidth, high capacity network. So it's got the capacity to do what you need it to do. So it's something to be thinking about. Don't just look at it from purely a data sense. There's a lot of capacity there that you can utilize. And the one thing I would say is don't just focus on that first material cost rollout. Focus on what the total solution is, what you're trying to do, and really think about long-term how you're going to be connecting in customers and what makes most sense and what kind of labors you're going to have available to you as you turn up customers. Any questions? Very quiet network. All right, well, thanks everyone.